In this video, we'll be looking at 0.4, the Pythagorean Theorem. And our essential question will be, what is the Pythagorean Theorem? And how do I use it? So before we can dive into the Pythagorean Theorem, we have to know the basic parts of a right triangle. So I'm going to draw a triangle, a right triangle. Like so. We'll put our right angle in there. And we have three sides, but we have two different types of sides. So we have this side called a hypotenuse. And then these sides will each be called legs. So the hypotenuse is the side across from the right angle. And that's like an always statement. So whenever you see a right angle, the side across from it will be the hypotenuse. And the legs they're the sides that come together to create the right angle. So these sides, how they're coming together like this way and that way, and where they meet is the right angle. So that's what makes them the legs. So when we're looking at the Pythagorean theorem, it's better to think of it conceptually rather than just the letters that we've seen in the past. So our Pythagorean theorem So our Pythagorean theorem is a leg squared plus a leg squared equals a hypotenuse squared. But let's label these so that we can say we'll call this one leg 1 and we'll call this one leg 2. So we're going to square both legs, add them together, and that's equal to the hypotenuse squared. So the Pythagorean theorem is really the idea of the first leg squared plus the second leg squared, and that's going to equal our hypotenuse squared. But we don't want to write this every time, so oftentimes the triangle is labeled like this, where the legs are A and B, and our hypotenuse is C. And so the equation we tend to build is A squared plus B squared equals C squared. Now we're going to use this to solve some different right triangles. So we're going to do two examples where we're solving for two different situations. So this first situation will be solving for the hypotenuse. And we'll have this right triangle that we're trying to solve. So we plug into our formula. We're just going to be using A squared, that's the leg, plus B squared, our other leg, is equal to our hypotenuse squared. So I plug in my values. So I have 5 squared plus 12 squared equals x squared. And now we go about simplifying. So I'll get 25 plus 144 equals x squared. Combining my constants, and I have 169 is equal to x squared. Now, this is kind of the tricky part is I got to solve for x. Well, to get rid of an exponent of 2, I just take the square root. A square root kind of undoes a square. So if I take the square root of one side, I then have to take the square root of the other side. And then when we punch this in our calculator, we'll get that x is equal to 13. And that's how we can solve for the hypotenuse. So we'll just plug in our numbers, we simplify, combining our like terms, and then to solve for x, I have to take the square root of both sides. Now what if we're solving for a leg? So we'll have a right triangle. We'll say this is our x. We'll call that 8. And we'll call that one 17. And we're just going to plug into our formula. A squared plus b squared equals c squared. So leg squared plus the other leg squared equals the hypotenuse squared. So I'm going to say 8 squared plus x squared is equal to 17 squared. So we'll be simplifying. And 8 squared is 64 plus x squared equals, and then we'll do 17 squared, and we get 289. Now I'm solving for x. I'm trying to get x by itself. So we'll have to use some inverses. So if I have a positive 64, the inverse would be subtracting 64. So we'll subtract 64. We'll do the same thing to both sides. Those will cancel. We'll bring down our x squared. we'll have x squared equals 289 minus 64. It's 225. And then we'll take the square root of both sides to get x by itself. So minus square root, square root. Let's see if it's a perfect square, so I can type it in my calculator. So I'm going to go the square root of 225. That's a perfect one, so we're going to make it as 15. They're not always going to be perfect. In fact, most of the time we'll have to simplify the square roots. But these two examples that we'll have are, so we'll have x equals 15. And that's how we solve for a leg. We plug our leg in, 8 squared. We plug our other leg in, that's our x squared. We plug our hypotenuse in, that's our 17 squared. Then we're simplifying. 8 times 8 is 64. 17 times 7 is 289. I'm then subtracting 64 from both sides. I'm trying to get x by itself. So now I have x squared equals 225. To get rid of that square, we square root both sides, and we get x equals 15. And that is how we can use the Pythagorean theorem to help us find different sides of a triangle. Thank you very much. I hope you have a great rest of your day.